Hey guys, I'm back with another one-dimensional kinematics problem. It's acceleration once again, except this time we're going to focus on giving the answer in terms of g's. Okay, so a car in a tire commercial moving at constant speed travels 105 meters in 4.5 seconds. If it hits the brakes and comes to a stop in 3.5 seconds, what is its acceleration in meters per second squared? Express the answer in g's, where 1 g is equal to 9.8 meters per second squared. Now, if you haven't learned this yet, the reason a g is equal to 9.8 meters per second squared is because that is the acceleration due to gravity, okay, very close to the Earth's surface. Okay, the number doesn't really fluctuate that much if you go above the surface, but nonetheless, there it is. Okay, so like I mentioned in the previous video, the first thing you want to do with any of these types of problems is always draw a picture. And sometimes it's not even really a sketch, it's just a schematic of what the problem looks like, the variables you have. Okay, that's what it comes down to. Okay, so we've got two segments to this problem, so I'm going to draw two segments here. Okay, the first segment, you've got a car traveling at a constant speed, okay, and it travels 105 meters in 4.5 seconds, okay? So the distance is 105 meters, the time is 4.5 seconds, and we've got a speed there, okay? The second segment takes 3.5 seconds. We're looking for the acceleration, okay? And we know one more piece of information. Now, it wasn't directly given to you in the problem, but you have to figure it out based on the words. Okay, and that is, it hits the brakes and comes to a stop. Okay, just like the previous question where things started from rest, and you would say v1 equals 0, whenever you have a problem where something comes to a stop, that tells you the final speed is 0. Okay, so the speed over here is going to be 0 meters per second. That's right there at the end. Okay, so this is what the problem comes down to. Okay, you've got a final speed here. You know the time to go from this segment to this segment. You're looking for the acceleration. So there is one very nice equation you can use to solve this, okay? And it involves the initial speed as well. But we're not given the initial speed, so you have to be a little bit creative here. How can you figure out the initial speed? Okay, so v naught. Okay, so if you think about it, the car is going 105 meters, taking them 4.5 seconds. So whatever speed you get from this calculation is going to be the speed that you start braking at. Okay, so we have to figure that part out first. Okay, so I'm going to go ahead and call this segment 1, and I'm going to call this part segment 2. Okay, so let's go ahead and calculate the speed for segment 1, which is going to become the initial speed for segment 2. Okay, so let's go ahead and get that done. So v equals d over t. Now I'm going to call them t1 and t2 because you don't want to mix them up. And I'm going to call this distance here d1, again, just to keep it clear. So v equals d1 over t1. Okay, d1 is 105 meters. t1 is 4.5 seconds. Okay. When you calculate that out, it equals 23 meters per second. And that is actually v naught. Okay, so we're going to use that in part 2. Okay, so moving on to part 2, we're looking for the acceleration. So a kinematics equation you can use is the following. Okay, your final speed v is equal to the initial speed v naught plus a t. Okay, if you're not sure where that comes from, or if you have trouble remembering that, it's a simple derivation. So if you remember in the previous video, I said, if you remember the definition of one of these kinematics constants, you can figure out what the equation is. Okay, so remember, acceleration is the change in velocity over change in time. Okay, so acceleration is delta v over delta t. Okay, delta v is v final minus v initial over the time interval. If you rearrange this formula for v, okay, you multiply the t across and you add the v naught, you get v equals v naught plus at, which is exactly what you have there. So again, if you forget the formula or your class is required to memorize it, you just need to remember this simple definition and the rest comes from that. Okay, so let's go ahead and start plugging in our numbers. So v naught, we just found it's 23 meters per second plus at, Okay, so the acceleration is what we don't know. So A, time is 3.5 seconds, and our V is 0. Okay, so you can see in this case, using the original equation is actually better. Okay, so if we actually rearrange this, A equals, okay, so you do 0 minus 23, which becomes negative 23 meters per second, and you divide it by the time, which is 3.5 seconds. Okay, if you calculate that out, you're going to end up with minus 6.6 meters per second squared. Okay, so we figured out the acceleration in meters per second squared, and actually just make sure that answer makes sense to you. It's a negative acceleration. Okay, the speed is positive, and if the acceleration is the opposite sign, that means the acceleration is in the opposite direction. Okay, therefore, having these two having opposite signs implies that the tendency of the vehicle or the object in motion is to slow down. Okay, if they were the same sign, that means it's in the same direction. It's going to enable it to go faster. Okay. Okay, so that's the acceleration in meters per second. Now it's a simple matter to convert it to G's. Okay, it's the same way I've taught you in every single other problem. Okay, so hopefully at this point you know how to do it. Okay, so you've got the acceleration minus 6.6 meters per second squared. Okay, we are actually told in the problem, so if you remember, we're told that 1g equals 9.8 times 10 to the, well, 9.80 meters per second squared. Okay, so we're going to do this multiply by 1. Okay, you replace that 1 just as before with a giant bracket with a line in the middle. Okay, we're trying to get rid of meters per second squared, so we put that in the bottom, and we're trying to achieve the unit of G, so we put that on top, and the ratio of G to meters per second squared that gives us 1 is 1.00 G's is equal to 9.80 meters per second squared. Okay, so writing it like this allows us to cancel out the meters per second squared, leaving us with the correct unit of G's. Okay, and if you calculate that out, it's just going to be minus 6.6 divided by 9.8. You get minus 0.67 G's. Okay? So to put that number into context, to make sure that actually makes sense to you, sometimes if you have very fast airline pilots or even astronauts that get launched into orbit, they're presented with a force of many G's. Okay, so not so much a force, but more of an acceleration. Okay, so if you're actually subjected to a very high number of G's, you can pass out because the blood leaves your head. Okay, so you actually become unconscious. So this number does make sense. Okay, again, the fact that it's negative implies that it's opposing the direction of the initial speed. Okay guys, so that's it for this video. If you enjoyed it, if you learned something from it, be sure to give that like button a click. Subscribe to my channel so you can be sure to catch all the other physics videos and any physics video that came before this, and so you can be notified of new videos that I make. If you think someone else can benefit from watching, be sure to send it to them via Facebook or Twitter. And other than that, I will see you guys next time. Okay, have a good day, and I'll see you later.